Hello, let's continue our Sudoku adventure with Double Jeopardy by Rangsk. That's me. So yes, I made this puzzle and I made it as an introduction to the new theme week. So the first Monday of every month, we do a theme week. And this is theme week number 3 for November. And the theme is doublers. So stay tuned for what that means. Every puzzle this week will use the doubler constraint, along with another constraint that is affected by the doublers. All right, so I'm going to go over the rules very carefully to this puzzle and pay attention to the doubler rules because those are going to be the same for the whole week. All right, so what are the rules to this puzzle? Well, in every row, every column, and every 2x3 box, we are placing the digits 1 to 6 exactly once each. Now, when I say digits, I do mean the digits. So we're going to end up with 1, 2, 3, 4, 5, 6 somewhere in each row, column, box. Now, normally I don't specify that, but it's going to be important for the doublers. So I'm going to be using the words digit and value, which normally in a Sudoku are interchangeable. But once we introduce doublers, it's important to pay attention to whether we are saying digit or value. So the reason for that is there are 6 doublers hidden in the Sudoku grid. So exactly 6 of these cells will be doubler cells. Let's say this ends up a doubler. What that means is that whatever digit goes in there, its value is double the digit. So the value of this cell would be 4 instead of 2, as it would be normally. All right, so every digit from 1 to 6 is doubled in one and only one doubler cell. So we're gonna have 6 doublers, 1 for each digit. So let's say this was a double 2. I'm not allowed to put another double 2 anywhere. So if I know that this is a doubled cell, I now know that it cannot be a 2. Could be a 3, it could be a 4, but this is not allowed. We can't double the same digit in 2 different places. Additionally, you can't have 2 doublers in the same row, column, or box. We can't have 2 doublers in this column, right? This would not be allowed. So we could do this, right? It's not in the same column, it's not in the same row, it's not in the same box. But we couldn't do this because they share a box. So it's just like Sudoku rules for digits, except the doublers also follow that. Every single row, every single column, every single box will have exactly 1 doubler in it. You can use that property. So remember both of those things. Every row, column, box has exactly 1 doubler, and each digit is doubled exactly once. All right. Additionally, we do have killer cages in the grid. The values within each cell that are in the cage sum to the clue in the top left. So the value sums to 5 here. So I could do 2, 3 with neither of these doubled, and that would add to 5. Or I could do, say, 1, 3, and I could double the 1. And if so, this would still add to 5 because the value of this cell is double the 1, so it's 2 plus 3. So it kind of subverts your expectations there. Now, I do want to point out, just very carefully here, just because I have a doubled 1 here doesn't mean I can repeat the 1. Respect the conflict checking here, right, if you have it on. But even if you don't, you can't, the row is still going to end up with the digits 1 through 6 in it. We're not going to be repeating a digit even if there's a doubler for that digit, right? So you can just do Sudoku as normal as you'd expect it to work, ignoring the doublers. It's just for, in this puzzle, it's just for the cage sums that you're going to care about the doublers. And then also the fact that doublers can't repeat digits within them, right? You can't have 2 doubled twice. All right. So I'm being very careful about going over these rules. Hopefully that's understandable. There's a link in the description if you'd like to try the puzzle yourself. And I'm going to get started right now. All right. The place that I want you to start is row 1, column 1 here. 21 is very big. If you think about normally in a 6x6, right? The entire row or the entire box would add to 21. So something's up here. We know there's going to be a doubler in here because we're not going to be able to reach the value. So if we were to do 4, 5, 6 in here and we didn't have a doubler, we would add to 15. We need another 6 to get to 21, which means that the only option is to do 4, 5, 6 and then double the 6. 21 is actually the biggest you can make 3 cells. So there's going to be a doubler somewhere in this cage, and it's going to be a 6. I'm going to use 6 corner mark to try to remind myself that I now have used up the 6. 6 can't be doubled elsewhere. Additionally, what I'm going to do is I'm going to gray out all of these cells to signify that they can no longer be doublers because we know there's a doubler in one of these 3. It can't repeat in the box and it can't repeat in the row. All right? So now we know this 19 has a doubler in it, which is good because again, 15 is the biggest you could do. But we also know the digits that go in it because 4, 5, 6 need to go in this box somewhere. If you want, we can fill 1, 2, 3 in all these and it makes it a little bit more clear, or you can use the roping. That 4, 5, 6 goes in there. So 4, 5, 6 adds to 15. What do we have to double to get to 19? We have to double the 4. So there is a doubler in here and it is doubling the 4 to get to 19. All right. Next, I hope your eye is drawn to this 2 cell 16. Even in a 9 by 9, 16 is pretty big for 2 cells. But certainly it's big here. Now, here's the thing. 6 and 4 are already doubled. So what happens if, we know there's going to be a doubler in here because 5, 6 would be the biggest we could put in it. And that's only 11, right? So we got to double something. Now, if we do 5, 6, we double the 5, right? Is there any way to get away with not doubling the 5? And the answer is no, because we can't double the 6, we can't double the 4. If we double a 3, that's only 6. We could do 3, 6, but that 3 doubled is 6 plus another 6, right? We could do that with the 3 doubled, but that's only 12, right? So what we have to do is we actually have to do 5, 6, and then the 5 is doubled. We don't know where it goes, but the 5 is doubled. So this 5, 6 pair does make this a 4. The 4 is not doubled here, so this is not a doubler. All right. Now the next thing that I would like you to look at is this 15 cage. So 4, 5, and 6 are all doubled. So we can't double any of those. But also, we can't do a natural 15 because there would be too many 4, 5, 6s in this row. Where are we going to put 1, 2, and 3, right? How are we going to fill all these? It's not going to work. So something is going to get doubled in this 15 cage. Can we get away with only doubling something smaller than the 3, right? Can we double the 2, for example? So if I do a double 2, let's just think about this. That would be, well, first of all, it means we have a doubler in it. So actually that's going to make things a little bit easier to think about. We know there's a doubler in here. So first of all, we know there was a doubler in there already. I should have marked these not doubler. But now the rest of this box is not doubled. This is a natural 7. But it also means this can't be doubled. So that means it's the 6 and this is the 5. So the 6 is gray and the 5 is green because it is doubled. So this is our first known exact doubler location. So now we can't even put a 6 in this 15 cage. And we know there's a 5 in it and we know it's not doubled. So can we double the 2? That's the question. Can we double a 2 and then put a 5 and then put something like the biggest we could put is a 4, right? So these would add to 9 and then we add 4 to that, doubled 2, and that doesn't get big enough, right? That would only be 13. So we have to double the 3. So we know there's a doubled 3 in here. And then, so that's 6. So we need 9 more. How are we going to do 9? Well, we're going to do 4 and 5. So this is 3, 4, 5. That means that this has to be 3 and 4. And that means this is 1 and 2. And so now we know this is 1, 2, 6. To get the 7 cage to work, this has to be 1, 6. And we place the 2. That's not a 2. All right, so now this 2 looks at this cell. So we know this cell now can't be a natural 2. So the only way we're making one cell be a value of 2 is to double a 1. So that means these are not doublers. That makes that a 3. It means these are all gray. All of these are gray now because they cannot be doublers anymore. Oops, wrong gray. All right, this is not a 3. This is not the 4 because the 4 needs to be doubled in this cage. 5 doesn't have a doubler in it, and it's no longer 1 plus 4, so it is 2 plus 3. So that is not a 3, so it's not the doubler because we know the doubler is the 3. So this is the doubled 3. If I can do this right. There we go, that's the doubled 3. And let's see. These are from 1, 2, 3, that's not a 1. So that's a 2, 3 pair. These are from 4, 5, 6. All right, how do we want to continue? This is 4, 5, 6. So these are not doublers either. So we know one of these 2 is a doubler. Can this be a doubler, I guess is a question. We're doubling the 2, right? That's the only thing that's left. We have 1, 3, 4, 5, and 6 already doubled. The last doubler is a 2, which means that one of these 2 will have a 2 in it. So we can actually make progress just from that deduction. Because the doubler will be a 2 and it's in one of those 2 cells. And we can get a bunch of digits from that actually. Okay, but now we actually have to think about it. If this was a double 2, this would be a 1. That adds to 5. But also, if you think about it, the only way you could use a double 2 in a 2-cell 6 gauge would be to would be to put another 2 in it, right? Because 4 plus 2 is 6. So there's no way this is the double 2. This is the double 2, and that gets us to the 1 and the 5. It also tells us that this is the non-doubler, and this is the doubler, and this is a doubled 6. If you remember, we get the 4 here, we get the 6 here. That 6 plus 4 is 10, so that works. That's not 5. This 3 told us that what this was a while ago. I just never did it. So this is the doubled 4. We get the 6 and the 5. We get the 4, the 5, the 4, the 6. And we just finished the puzzle. All right, there we go. And that's the correct solution. So hopefully that gives you an idea of how you're going to be handling doublers for the rest of the week. I hope this was a nice intro puzzle to how doublers work. Doublers just naturally add a bump in difficulty to any puzzle. So we worked really hard to try to make these approachable, but I will say this week might have some sort of higher difficulty than we're used to puzzles. But our setters worked really hard to try to make these approachable and nice introductions to the doubler rule set, and also tested each other's puzzles and gave very frank feedback. So hopefully we did a good job. You can let us know how you felt about these puzzles. And of course, if you are enjoying this series, then why not leave a like, subscribe, and a kind comment below.